Hi, hello. This is Linu. Welcome to Linvis. I hope you all are doing well. In today's video, we are going to dive into VSEPR theory from the chapter of chemical bonding. So make sure you stay till the end of the video. You will get some amazing tips and tricks so that you don't want to miss that, right? So don't forget to hit the subscribe button and ring the bell icon so you will never miss an update from us. So now let's get started. VSEPR theory, as the name suggests, it is, as the name suggests, VSEPR theory. So let us discuss about VSEPR theory. So from the name itself, you will get the complete information about this theory. That is, V for valence, S for shell, E for electron, P for pair, R for repulsion. That is valence shell electron pair repulsion theory. Very simple, right? And we already know that for an atom, for an element, it will have a valence shell, right? There will be electrons in the valence shell, right? Electrons are already negatively charged particles, so they will automatically repel each other, right? That is explained by this theory. Got an idea? So, the repulsion of the valence shell electron pairs. Okay, that is explained by this theory. So, we will get the shape of the molecule using this theory. Okay, we can predict the shape of the molecule when you use this theory. Okay, yes. Now, let us move on to the main postulates of the theory. First postulate that I have already mentioned, shape of a molecule depends on what? It will depend on the valence shell electron pairs, whether it is bonded or without doing anything, that is non-bonded around the central atom. Okay, so pairs of electrons in the valence shell repel each other, right? Because electron clouds are negatively charged, they will repel each other. And when they repel each other, what will they do? Yes, they will automatically try to minimize the repulsion, right? To attain more stability, they will automatically go to such positions in space, okay, to minimize the repulsion and thus maximize the distance between them, okay. And we are taking the valence shell as a sphere, okay, where the electron pairs localizing on the spherical surface. Okay, so these are the main postulates, and you have to understand two main things, that is lone pair and bond pair. This is two new words here. Okay, so lone pair means the electron pairs. So these are electron pairs without involved in the bonding. Without involved, they are not taking part in bonding. They are sitting very freely. Okay, involved in bonding. So what will be bond pair? Yet that is involved in bonding. Electron pairs that is involved in bonding. Okay, that is only difference. And one more thing you have to understand here. Always there is nothing to do with this lone pair, right? Because they are not participating in bonding. They are sitting very freely. So if there is two like lone pairs, their repulsion will be very greater. Lone pair repulsion. Okay, that will be very greater compared to lone pair, bond pair. And after that comes bond pair, bond pair. So you have to understand, we have to understand what is the, who is having greater repulsion. Okay, lone pair repulsion is greater than lone pair, bond pair. There comes bond pair repulsion. Okay, hope you get the main idea about VSPR theory. Now we are going to discuss about what is going to happen for the electron pairs and how they are arranged in space, that all things. Okay, let us move on. Okay, so we are going to, before that, I want to explain you about the shape of the molecule and what is mean by geometry. Okay, so you must understand the difference between a shape and geometry. I already mentioned that shape is determined by VSPR theory. That is, for mentioning the shape of a molecule, we have to consider only its bond pairs. Okay, we are not worry about what is happening to its lone pairs. Okay, yes, got it? Yes, but in order to explain the geometry of a molecule, we have to consider both lone pairs and bond pairs in a molecule. That is the only difference. Okay, yes, let us move on to what is happening. So we are going to discuss the first one as Only electron pairs, which is bond pairs. There is no lone pair case. Okay. Only bond pairs. Bond pair electrons. Okay. Bond pairs. Okay. Then we have to find its what we call shape. And I will explain example also. Okay. We will study in detail about the examples also. Okay. Yes, let us move. The first one is having bond pair of electrons 2. 2 bond pair 2. 2 electron pairs should be there. Then only there will be repulsion, right? Yes. So 2. Starting with 2 bond pairs. For example, we can write this as AB2. 2 bonds. 2 bonds for this A. That means 2 electron pairs. 2 bond pairs. Okay. So how will they arranged? Maximum distance. How can to imagine two students are quarreling in the class? They are very much making problem in the class. So what would the teacher do? Teacher would sit them as far as possible, right? Like that. In order to minimize the repulsion of these two bond pairs, this has to put them as far as possible like this. Okay. So you will get an angle of 180 degree, and this is very linear, right? So its shape is linear. Okay, its shape is linear. And I will explain with example, that is BeF2 or BeCl2. Okay, how many electrons are there for beryllium? Beryllium is having 4 electrons, right? Beryllium's atomic number is 4, and it is 2, 2. There are 2 electrons for beryllium atom. Okay, 2 electrons in the valence shell, and it will be shared with 2 fluorine atoms. Fluorine is in need of 1 more electrons, and they are sitting like this. This is beryllium fluoride structure, linear structure. Hope you understand, right? Yes. Now moving to the next 3 pairs. Now we have to go 2, 3, 4 like that. Okay. So 3 bond pairs means AB3, AB3. How will we arrange them? Maximum distance apart. So we have to arrange A here. And what you have to do, you have to make this like this. That is like a triangle. Okay, like a triangle, you have to put the electron pairs B, B, B. So you will get a shape of, what is this shape? Trigonal planar, like a triangle, right? Trigonal planar with a bond angle of 120 degree. With a bond angle of 120 degree. And which example we will see here? BF3. So boron is atomic number 5. It is having 3 electrons in its valence shell. So how will you arrange the boron? B here 1 electron, here 1 electron, here 1 electron, which is shared with 3 fluorine atoms. Okay, forms this bond, and the shape is 120 degree, and shape is triangular planar and angle of 120 degree. Okay, yes, this is the shape. Okay, next we have to move on to the 4 electrons, 4 bond pair electrons, that is AB4. So when you understand this is 4 electrons, so just you will think about writing like a cross, right? So B, 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 no. But actually here in this case, when you draw like this, it would be 90 here, 90, okay, 90. So there is another important possibility. Okay, there is another angle that is possible to keep them. Okay, very strong angle. So what is that? We can make them like this. A here, and you can make a pyramid like this. And this shape is called as tetrahedral, and its angle is greater than 90. That is why we choose here 109.5 degree. Okay, and for example CH4, there is no lone pairs here. Carbon is having only 4 electrons in the outer shell. It is all shared with hydrogen atoms. There is no lone pairs here. Okay, so yes, so this forms a tetrahedral shape. Okay, yes, moving to 5 electron pairs. 5 electron pairs, how? A, B, 5. Okay, so for that we have to make this A here, and 3 bond pairs in the same plane like a triangle. Okay, like a triangle, 3 bond pairs in a same plane, and one above and one below. Okay, one above and one below. And this is a triangle pyramidal. Okay, what is this? Trigonal, two pyramid, up and down, right? Trigonal bipyramidal structure, 5 electron pairs. Okay, and here this triangle's angle is 120 degree and this is 90 degree. Two bond angles are here. Okay, two bond angles, 120 and 90 degree. Best example is PCl5. PCl5. So phosphorus is having 5 electrons in the valence shell. Okay, that 5 electrons are shared with the chlorine atoms. There is no lone pairs here. 5 bond pairs. So its shape is trigonal pyramidal and a bond angle of 120 and 90 degree. Okay, and the last one is six bonding electron pairs. That is AB6. This is arranged in the form of octahedral shape. Okay, octahedral shape. How this shape looks like? We can draw a central A here. Okay, A here. Then how does this octahedral shape shows? Yes, like this. Okay, B. All B's. Okay, B, 6 B's. This is octahedral. So which is the most common example is VSEPR. Sulfur is having 6 electrons in its valence shell. It is bonded with 6 fluorine atoms. You get a octahedral shape. Okay. Yes, there is no lone pairs in this case. So now we discussed about what is the case without lone pairs. Okay. So first one is linear shape. 2 electron pairs. 3 electron pairs means trigonal planar. 4 electron pairs means tetrahedral. And 5 electron pairs means trigonal bipyramidal, and 6 electron pairs means octahedral. Okay, so hope you get it. Okay, everything clear? Any doubt you can mention in the comment. Okay, comment box. So I will clarify that. Okay, now moving to the bond pairs and lone pairs. What will happen when there comes bond pairs as well as lone pairs? Okay, let us see. It is very simple. If you understand the concept like this clearly, you will get everything. Okay, very simple text. Okay, now we are going to discuss about first one, bond pair 2. This is bond pair and lone pair 1. Okay, so bond pair is the, lone pair is the, total 3. Okay, you can see here we can write like A, bond pair 2, lone pair 1, like this. Okay, total how many? 3, right? Total bond pairs is, sorry, total electron pairs is what? Total, let us think about total electron pairs is 3. In this case, where total electron pairs was 3, what was the structure of that? Trigonal planar, right? Total one was what? Trigonal planar, right? Yes. So in order to find the shape, we are not considering about lone pairs. I told you, right? There is only bond pairs we are considering. For example, let us discuss. So A is here. This is A. When there is 2 bond pairs, what was the structure of that? This one, right? BB. But here there comes a one lone pair of electrons. So what will happen? Because of this repulsion of lone pair, these bond pairs will be like this. Okay. Okay. Because of this lone pair, bond pair repulsions. Okay. So what will happen? It will get which shape? It will get an angular shape. We call it as angular. Or another name is a bend shape. So because of the repulsion, that bond pairs has to bend a little bit. Okay, that is happening. Okay, let us consider one example. That is example of SO2. SO2. Okay, sulfur is having how many electrons in its valence shell? 6 electrons, right? So 1, 2, 3, 4, 5, 6. It is shared with oxygen atom. Okay, here like this. Okay, oxygen is having 4 electrons. Okay, then here also 1, 2, 3, 4. It is also shared. So there is one lone pair electrons, right? So it will form a structure like SO2, like this, and a lone pair is sitting here. So this is having a bend shape, yeah, angular shape. Okay, hope you get it. Like, right. Moving to the next one, having electron pairs. Okay, here we have written bond pair. Okay, so here bond pair again 2, bond pair is again 2. So we have taken bond pair 1 for the last case. So here we are going to take 2 bond pairs. Okay, so this is the case of A, B2, lone pair 2. Bond pair 2, lone pair 2. Okay, so what will be its shape? So total of how many bond pairs? 2 bond pairs. We expect to be linear, but because of this bond pair, lone pair as well as lone pair, bond pair repulsion, what is happening to the case is, yes, see the case bend shape. Again, just think about the water. Water is having 2 lone pairs, right? And hydrogen like this. So here also we will get which shape? Bend shape. Bend shape. Okay, like this. Okay, so this is A central atom. This is B, and 2 lone pairs are sitting here. This is also bend shape. Okay, yes. Moving to the next one, 3 and 1. That is 3 bond pairs, 1 lone pair. Okay, that is AB3L. AB3L. Okay, so let us draw the structure. A here, B here, 1B here, 1B here, and lone pair is sitting here. So we are expecting a tetrahedral structure for these because total there are 4, right? Both are having total 4. So we are expecting a tetrahedral shape, but actually we are not considering the lone pair. So you'll be getting this is like a pyramid, right? This is like a pyramid. We are getting a pyramidal shape. Most common example we know ammonia. Ammonia is having 1 lone pair of electrons, right? So ammonia's shape is pyramidal, right? This is the case. Hope you understand. Now moving to the next one. Yes, next is 3-1. Okay, that is bone pair 3, lone pair 1. Okay, bone pair 3 and lone pair 1. What is structure? A B3L. A B3L. What will be the structure of A B3L? Yes, it is 3 bone pairs and 1 lone pair. Oh, we already mentioned that. 3 bone pairs here, 1 lone pair. Okay, we mentioned that. Then 3-2. Next is 3-2. 3 bone pairs and 2 lone pairs. L2. Okay, 3 bone pairs and 2 lone pairs. So how will be the shape? Okay, so let us see the shape here. 3-2 will be like, okay, 3 bone pairs we will draw like A, B, B, B. Okay, B, 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 and 2 lone pairs will be sitting here. What is this shape? Just you will understand this is a T shape. T shape. For example, ClF3. Chlorine is having 7 electrons, right? Chlorine 7 electrons. Okay. 3 is bonded to fluorine. Okay, three of them is bonded to fluorine and 2 lone pairs are here. So you'll be getting a T shape for that. Okay. Now let us consider about 4 bone pairs and 1 lone pair. Okay, A B4L. Okay, B4L. 4 bone pairs. So how will you arrange that 4 bone pairs? So A here, 1, 2, 3, 4. Have you seen this in the parks? My kids plays this. They like this very much. This is seesaw. Seesaw shape. We are not considering lone pair. How many lone pairs are here? Yeah, here it is 1 lone pair. This is here. This is like a seesaw shape. Okay, seesaw shape. Now next is, yes, next we have A, B, 5 bone pairs and 1 lone pairs. 5 bone pairs and 1 lone pairs. After there are total 6, we expect to be octahedral because of the presence of what? Because of the presence of 1 lone pair of electrons. How will the shape be like this? 1, 2, 3, 4. Yes, 5. But here it is lone pair. Okay. Here it is lone pair. So what will be the shape of this? Yes, this is square pyramid. This is square pyramid. Okay, there is only one pyramid, right? Yes. Then what will happen if there is total 6, that is 5 and 2? 5 and 2 means what? 5 and 2 means there is A here, B, P, B, B only. Okay, that is A, B, 4, L2. 4 bond pairs like this and 2 lone pairs, right? It is sitting here, it is sitting here. So its shape will be square planar. Give an example of XCF4. Yes, xenon is having 8 electrons, right? So 4 electrons are bonded. There is already 2 electrons. So Xe like this. It will exist like this. 2 lone pair here, 2 lone pair here, like this. Okay. Yes, this is square planar. Okay. And in the case of square pyramid, what is the example of IF5? IF5 is the example. Okay. I is having 1 lone pair will be there and 5 bone pairs. So it will exist in the shape of square pyramid. So it is better you have to understand the concept. Whenever example is given, just think how we can arrange it. Okay. So how we arrange it, you can understand it very easily. Okay. Now let us do one question related to that. So you will get some idea about how to work out the question. Okay. You have to match the following. Okay. There is simple question. You guys have to do the match the following. Yes. EXCF4, then IF7, sorry, IF5, then BRF3, EXCO3. Okay. Yes. Now do that. First of all, XCF4. XCF4 means xenon. Xenon is having 8 electrons. 8 electrons. Okay. And 4 electrons are shared with who? Shared with fluorine atoms. Okay. 1, 2, 3, 4. 2 lone pairs are here. So this is like square planar. Right? Square planar. Then IF5. How will you draw that? Iodine. Iodine is the central atom. 5 bond pairs. Okay. And there is 1 lone pair for iodine. 7 electrons in total. So how will you arrange? 5. 1, 2, 3, 4, 5. It's like a square pyramidal structure. Okay. Then fluorine. You have to place fluorines here. There is only 1 lone pair, right? So this is what? This is square pyramidal. And what is this? BRF3, Br, bromine, is having 7 electrons and it is bonded with how many fluorine atoms? 3 fluorine atoms forming a bond. 3 fluorine atoms. Okay. How many lone pair of electron? 1, 2, 3, 4, 5, 2. 2 lone pairs like this. So what is its shape? It is T shape. So inside the match following, everything is given. You have to just match. So I am explaining how to find. Then XCO3. What is the structure of XCO3? Yes, Xc is having how many electrons? It is having 8 electrons. Okay, 8 electrons. Okay, it is bonded to how many oxygen atom? 1, 2, 3, 4, 5, 6, 7, 8. Oxygen atom, 3 oxygen atom, right? So 3 means oxygen needs 2 more electrons. So here, like this. So this is 3 bond pairs, 1 lone pair. What is its shape? 3 bond pairs, 1 lone pair comes. We will get what shape? Pyramidal shape. Pyramidal shape. Pyramidal shape. Okay. So double bond and triple bond we are considering as 1 bond. Okay. 1 electron pair, not 2. Okay, 1 electron pair we have to consider. So this is similar to 3 bond pairs, 1, 2, 3 bond pairs and 1 lone pair. So this will under the category of a pyramidal shape. So we have this particular table in our textbook itself. That is, so everything is written in clear manner in this textbook. So you have to go through the all the number of electron pairs and its shape, and you have to study it. Okay. Yes, 2, 3, 4, 5, 6 or octahedral shapes and There is no lone pairs in this case. Okay, like that, whenever there comes bond lone pairs of electrons, what will happen to the shape? That is also here. Okay, so just go through the table, just understand the concept, and you will get complete idea about VSPR theory after watching this video. I hope so. Okay. Yes. That's all about VSPR theory. Thank you so much for watching. Yes, if you enjoyed this video and found it helpful, don't forget to give it a thumbs up and share it with your friends. Okay. Leave a comment below if you have any questions or any suggestions for the future videos. I would like to hear from you. And if you haven't already, make sure to subscribe, Learn this channel and click the bell icon so you will never miss an update. Stay curious, keep learning, and we will see you in the next video. Bye for now. Thank you.